Hello friends, good evening. I welcome you all to this session. So let us get started. So in the previous session, we discussed about the basics of what? First class, we discussed about first class, we discussed about basics of probability. That means the terminology is related to probability. In the previous class, we discussed about axiomatic approach to probability. So based on the knowledge that we gained in the previous class about axiomatic approach to probability, in this session, in this class, we are going to solve certain PYQs. PYQs based on axiomatic approach to probability, which have been asked in the examination, IIT JAM examination. All right, friends, let us get started. But before that, like always, I'd like to inform you about the upcoming course, that is Secure Below AIR 100, okay, IIT JAM Biotechnology, and also CAT-B and Common University Entrance Test PG for 2025 rank assurance program. It is a rank assurance program. The fee for the program is very nominal. It is 22K. Why I am telling nominal? Because you're getting complete access to the live classes, recorded classes in case you miss the live classes, and also very well crafted PPTs. Okay, that is the hallmark of Chandu biology classes. And next, and also you are getting study material, complete study material, and also mock test series. Okay, so what is the USP of this program? Well defined 6 months plan, interactive live and recorded classes. Okay, interactive live and recorded sessions, well crafted PPTs, 13 chapter wise and 10 mock tests. Okay, expert design study material. Okay, which has been completely reviewed by Dr. Chandrasekhar sir. Okay, next, when it comes to test series, you are having both section wise, that is 13 chapter wise tests and also 10 full length tests, 10 mock tests. Okay, and individual attention will be given to every student. Okay, how to prepare the timetable schedule for your studies. Okay, if you're working aspirant or if you're full-time aspirant and any doubt which you have which you couldn't ask in the class, you can directly connect with Dr. Chandrasekhar sir or with me when it comes to mathematics related for IIT JAM. Okay, IIT JAM and GAT-B. All right, friends. So this course we are having for both IIT JAM and also GAT-B and also Common University Entrance Test. That is for post-graduation, friends. Okay, so when it comes to GAT-B, the course is for 8 months, friends. Okay, got it? It is for 8 months. So both the courses are starting from when? It is starting from 1st October. Remember the date. So join as soon as possible and get started from 1st October itself. Okay, get started from 1st October itself. It is starting from when? 1st October. Okay, the plan is very well meticulously done as per the needs of the students. So based on that, we are going to conduct the classes. Okay, this is about our courses, which is going to start from 1st October, friends. Next thing is, we'll continue with our session. So in the last classes, these are the terminologies we learned. Okay, trial, sample space, outcome, what is an event, random experiment, all these things. What are types of events, mutually exclusive events, and next we learned about exhaustive events, then partition of sample space, and then we went to another concept, that is axiomatic approach to probability. That is, it is highly important topic. Okay, next we learned what do you mean by probability. Okay, the definition of probability. Then we learned about addition theorem for one event, two events, and also for three events. Okay, addition theorem, you have to learn only the formula, that's all. You don't have to learn the theorem, how it comes and all these things. That proof is not there for you. You do not learn that proof. You have to use the addition theorem. That's all. That is the theorem itself. That is why it is called axiomatic approach. These are the axioms which you are using in solving the probability questions. So one of the axioms is addition theorem. Got it, friends? That is the meaning of axiomatic approach. Okay. So we solved one of the PYQ in the previous class. That is when two dice are rolled. Okay. What is the probability getting a doublet, or sum of the faces as 4. Like this we solved. Okay. Next is, we learned that probability means cardinality of event, that is number of favorable outcomes divided by total number of outcomes. Number of favorable outcomes of event. Probability we are going to find for an event, not for an outcome. So probability of event is given by, we learned that probability of event is given by cardinality of the event, that is number of favorable outcomes with respect to this event divided by total number of outcomes, that is cardinality of S, that is sample space. So this is what we learned. Okay. Now, next thing is, we'll go on with next question when it comes to PYQs. Okay. So this question is saying, listen very carefully each and every word which I'm saying. A card is drawn from a pack of 52 cards. Okay. Most of you must have played with these cards. Okay. Those who have not played, I will tell you some knowledge about these cards. Without having the knowledge about cards, you can't solve such questions. So they are telling a card is drawn from a pack of 52 cards. The probability of getting a heart or a red card is a heart or red card. Okay, so there are two events. The probability of getting a heart or red card is. So this question is also from PYQ. All the questions which you are solving are PYQ. This is IIT Jam. Okay, 2024. Same year. IIT Jam 2024. Okay, friends. This is also a PYQ. Okay. So to solve the question on cards, first you must have knowledge of cards, right? You must have knowledge of cards. So when it comes to cards, let me tell you, please listen carefully because they're asking questions continuously on coins, on dice. Dice, I told you what are the type of questions that they are asking. I told you dice means what is the sample space, if it is single die, two dice, or three dice. Okay. Next, when it comes to cards, they can ask, mostly they will ask based on coins, they will ask based on dice, and they will ask based on cards. So already you have knowledge about coins and also dice. So today I'll give you some information about cards. When it comes to cards, remember one thing. When it comes to cards, there are total how many cards, friends? There are total 52 cards. Okay, remember this. Types of cards. When it comes to 52 cards, what are they? Types means they are of how many types? They are of 4 types, friends. They are of 4 types. Okay, there are 4 types. One is called heart. One type is called heart. Another type is called diamond. And the next type is called spade. Okay. And another type is called club. Okay. Another type is called club. And each of them, okay, 52 divided by 4 is how much? 13. So each of them have 13 cards. Heart is 13. Diamond is 13 cards. Spade is having 13 cards. Club is having 13 cards. Okay. So each of them has 13 cards. They're numbered as like this. Heart is numbered as like this. So A, 1, 2, 3, up to 10. And the 11th card is Jack. Then 12th card is Queen. And 13th card is King. Similarly for this one also. Diamond also. A, 1, 2, 3, 9, 10, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King. Okay. So similarly for what? Spade also. 1, 2, 3, up to 10, Jack, King, Queen. So A, 1, 2, 3, up to 10, Jack, Queen, King. So now if I ask you how many kings are there are total 4 kings. 4 kings. Total 4 kings. Queen is also 4. Correct, no? And Jack is also 4. Okay, Jack is also 4. You have to remember this. Okay, so out of 52 cards, there are 4 kings, 1 each from heart, diamond, spade, and club. And queens, there are 4, 1 each from heart, diamond, spade, and club. How many Jack are there? 1 each from heart, diamond, spade, and club. So there are 4 kings, 4 queen, and 4 Jack. When I ask how many A are there are 4 A's. Okay, 1 each from heart, diamond, spade, and club. So this is one type of classification. Another type of classification is based on colors. Classification based on colors. Based on colors, if I say there are 2 types. There are 2 types of color. One is red color. One is red. Another one is black. Okay, another one is black. Okay. I hope till here it is clear. First I told there are 52 cards. They are divided into 4 types. One is heart, diamond, spade, and club. Heart is having 13 cards. Diamond is having 13 cards. Listen carefully each and every word which I'm saying. And spade is having 13 cards and club is having 13 cards. They are numbered as A 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. So there are 4 kings, 4 queen, and 4 jacks, one each from heart, diamond, spade, and club. This is the one of the classification. Another type of classification is based on color. So one type of color is red, another type of color is black. Under red, what are the types of cards that come under the red? The types of cards that come is under red, the types of cards that come is heart. Okay, one is heart, another one is diamond. Okay, heart and diamond. Under black, let me use another color. Under black, type of cards that come is spade and club. Spade and club. Okay, okay, friends. So when it comes to colors, the type of cards that come is under red is heart and diamond. When it comes to black, spade and club. So under heart, we have what? A to 1, 2, 3, up to 10, Jack, Queen, King. Under diamond also same thing. Okay, under diamond also same thing. We are having A to A 1, 10, Jack, Queen, King. So when it comes to spade, we are having same thing. A 1, 2, 3. Okay, let me use another color. Okay, let me use another color for this. But this is in another color. Since the background is black, so that's why I'm using another color. Under spade, it will be black. Okay, under spade, it will be black. It will be A, spade also, club also, it will be same. A, 1 up to 10, Jack, Queen, and King. Okay, Jack, Queen, and King. So, if I ask you, how many red cards are there? How many red cards are there? How many red cards? So, if I ask you, now question, if I ask you, so this based on this question, you will gain some knowledge about cards. Okay, how many red cards are there? How many red cards are there? So it is heart plus diamond. Heart plus diamond is, it is 26 cards. How many black cards are there? How many black cards are there? It is, how many black cards are there? It is spade plus cup, it is 26. How many red kings are there? How many red kings are there? One is from heart and diamond, 1 plus 1. So there are 2 red kings. Okay, 2 red kings. Similarly, if I ask how many black kings are there? One is from spade and club. There are 2 black kings. Okay, friends, same thing for queen, same thing for jack. Okay, so 2 kings are from red and 2 kings are from black. That is, 2 kings are from red means one is from heart and diamond. When it comes to black, 2 black kings, 2 kings are from black cards. That is, one is from spade and club. So this is the knowledge you need to have. Okay, having the knowledge of this, with this basics knowledge about cards, let us solve the given question that is asked in IIT Jam 2024. I hope this much knowledge is enough for you when it comes to solving cards question. If further knowledge is required when it comes to solving PYQs, then I'll tell you there. Okay, all right, friends. Having said this, let us solve this question. So there are total of 52 cards. Okay, they're telling a card is drawn from a pack of 52 cards. A card is drawn from a pack of 52 cards. They're telling 52 cards. That means what? Number of sample space, that is total number of outcomes, or cardinality of S. Here, cardinality of S means what? Here, N of S. Here, N of S will be how much, friends? N of S will be 52. Okay. N of S will be 52. N of S will be 52. Then the probability of getting a heart or red card is. The probability of getting a heart or red card is. So there are 2 events. Okay. Event 1 is saying getting a heart. Okay. Event 2 is saying getting a red card. Okay. When you pull a card, the probability of getting a heart or probability of getting a red card. Okay. This is or they are telling. They are telling or. I told you when they say or, it is union. Okay. In the previous class itself, I told. If they say and, it is intersection. It is what, friends? It is intersection. You have to be very careful. The probability of getting a heart and a red card. If they say and, at that time it will be intersection. Okay, at that time it will be what? Intersection. At that time it will be intersection. But here they're telling or. Okay, here they're telling or. So this is what we have to follow for this question. They're telling or, so it will be union. So it will be union. Even getting a heart. For this, what is the sample space? Getting a heart is, okay, how many hearts are there in a pack of 52 cards? Just heart. They're not telling any color. So one heart will be from getting a heart. Okay, getting a heart. Just a minute. I told you there are 4 types of cards. One of the type is heart. Getting a heart means there are 13 hearts. Correct? No. One is, I told you, there are 4 types of cards. That is heart, diamond, spade, club. That is 13 hearts, 13 diamond, 13 spade, and 13 club. So getting a heart means there are enough E. That is enough even. Cardinality of even is how much? Cardinality of getting a heart is 13. Okay, because how many hearts are there in 52 cards? 13 hearts are there. Okay. Next is getting a red card. Getting a red card. See here, getting a red card. I told you here, I told you red cards. Red cards, what are the 2 types of red cards? That is, one is diamond, another one is heart. Okay, under diamond, how many cards are there? 13. Under hearts, how many cards are there? 13. So total is how much? So total red cards is 26. So here n of E2, that is cardinality of E2, that is favorable outcomes with respect to E2, that is getting a red card. Okay, total number of red cards is 13 plus 13, that is 26, friends. That is 26. Got it, friends? That is 26. Next thing is, you have to see even intersection E2, because when we use the addition theorem while solving this question, what will happen is we have to use even intersection E2. That is there anything common between even and E2? Okay, is there anything common between even and E2? Okay, getting a red card and getting a red card and getting a heart. Okay, so in red card there is heart also. Okay, here there is heart also. Okay, even is also having heart, E2 is also having heart, because red card will have diamond also and heart also. How many heart are there? 13. I'm talking about E2. How many diamond are there? 13. Out of this 13, this 13 is present in E1 also. E1 is talking about getting a heart. So 13 are common here also. 13 hearts, here also 13 hearts. Here also 13 hearts, here also 13 hearts. So E1 intersection E2, that is number of, that is cardinality of E1 intersection E2 is, what is common here? 13 is common. 13 hearts, here also 13 hearts, plus 13 diamonds. 13 diamonds is not common. Here only heart is common. So heart is common for between both E1 and E2. Okay, I told intersection means if there is anything common. So heart is common between E1 and E2. So heart, how many cards are there? 13. So here 13 is common. Now we have to find the probability. Okay, so what is the formula we have, friends? The formula that we have is, listen carefully, the formula that we have. Okay, the formula that we have is, what is the formula that we have? Based on the addition theorems here, the formula that we have is P of, we have to use R, no? R means E1 union E2. There, since they are telling R, I have to use union. P of E1 union E2 is probability of E1, okay, plus probability of E2 minus probability of E1 intersection E2. Got it, friends? So this is because we have the formula, that is P of A union B is equal to P of A plus P of B minus P of A intersection B. Why I am writing this? For your understanding. But in the examination, if you know the formula, directly you can put the values and solve. Okay, no need to write the formula. But still, can write the formula to be on the safer side so that you don't do any calculation mistake. So now we have this formula, but we don't know what is P of E1, P of E2, P of E1 intersection E2. So P of E1 is, friends, it is nothing but N of E1 divided by N of sample space. So that is nothing but what? N of E1 is 13. N of S is, here we got 52. Don't cancel anything, keep it as it is. Next is P of E2. P of E2 is N of cardinality of E2 divided by cardinality of sample space. So that will be equal to how much, friends? That will be equal to, we got it as 26 by 52. Next is P of E1 intersection E2 is cardinality of E1 intersection E2 divided by cardinality of N of S. Cardinality of S, that is N of E1 intersection E2 is how much we got here? We got it as 13. So 13 divided by 52. Okay, friends, 13 divided by 52. So what is the answer we get? So if I put these values in this equation, if I put the value, what I'll get is equal to P of E1 is what? 13 by 52. P of E2 is what? 26 by 52 minus what is the intersection? That is, what is the intersection that we have here? P of E1 intersection E2 is 13 by 52. Okay, friends, here I can cancel it. This is positive. That is 13 by 52 plus 13 by 52 minus 13 by 52. This and this I can cancel. So I'm left with only this. So this will be what? 2 13s are okay. 2 26 are okay. 2 26 are 2 13s are 2 26 are. Something is missing here. Let us check. Okay. One thing you must understand here, the question is not complete. Then the probability of getting a king is also there, friends. Just a mistake here in the question. Probability of getting a king. Okay, probability of getting a king. Let me write it here. Okay, nothing to worry. We'll make some modification. The probability of getting a king or heart or red card. Okay, getting a king or heart or red card. So getting a red card is there. Now we have to see event 3. Event 3, here I'll write it here. Event 3 is what? Getting a king. Okay, getting a king. Getting a king means event 3 is getting a king. Getting a king, how many kings are there? Okay, how many kings are there, friends? There are 4 kings. So n of s, n of e3, n of e3 will be 4. Remember this, n of e3 will be 4. So p of e3, will be how much, friends? P of e3 will be n of e3 divided by n of e3 divided by n of what? N of e3 divided by n of s. So that will be 13 by 52, P of E3. So this is fine. Okay, E1 intersection E2, that is also fine. But here, instead of using this formula, we have to use the formula that is there for this. Everything is fine. You have to use the formula that is there for 3 events. Okay, the formula that is there for 3 events because the question was incomplete. Okay, otherwise for 2 events, what we did for that, the correct answer. That is the correct answer. Nothing to worry about that. So see here, friends. Observe carefully. If the question is for 3 events, the formula will be also for 3 events. So the formula will be P of E1 union E2 union E3. So the formula is, so see, observe carefully. They're not asking just for 2 events. They're asking even for 3 events. So you have to remember the formula for 2 events also, 3 events also. Okay, very careful. Okay, so you have to learn the formula for both 2 events also, 3 events also, because it is asked in PYQs. They're asking up to 3 events. Then it is imperative for you to learn the formula for 3 events. Okay, I'm solving everything slowly so that you understand. So the formula for this will be P of E1 plus P of E2 plus P of E3 minus P of double intersections, P of E1 intersection E2. Next is min of P of intersection E2, E3 minus P of intersection E3 intersection E1 plus what? Intersection of all P of E1 intersection E2 intersection E3. Okay. First of all, we got this P of E1 intersection E2. We already got. Now we have to find out. E2 and E3. Okay. E2 intersection E3. E2 intersection E3. What is E2, friends? E2 is getting a red card. E2 is getting a red card. Next is E3 is getting a king. So when it comes to red card, there are diamond and heart. So diamond and heart will have one king each. So here, see here, E2 is getting a red card. Heart will have one king and diamond will have one king. Getting a king is, here there are two, here there are four. Getting a king, there are four. Each one is from diamond, heart, spade and club. So here heart is from, not heart, king will be from, one each from diamond, heart, spade and club. So here one, here one, here one. So it is four. Now this is about getting a king, getting a red card. Getting a red card means these two are red, no? Diamond and heart are red. So there are two kings. So E2 and E3, the common thing is there are two. N of E1 intersection E2, E3, sorry, E2 intersection E3 will be how much, friends? It will be how much, friends? It will be 2. Okay, it will be 2. So probability of E2 intersection E3 will be 2 by 52. N of E2 intersection E3 divided by N of S, that is 2 by 52. That is 2 by 52. I'll write it neatly here. That is 2 by how much? Is 2 by 52. Okay. The question was not complete. As per the PYQ, there are 3 events, but we took 2 events initially, but now it is 3 events. As per the PYQ, it is 3 events. It is very important to solve such questions. Okay, because they were given for 3 events. Now we have to find for E3 intersection E1. That is, or E1 intersection E3 or E3 intersection E1 is one and the same. So E1 is what, friends? Getting a heart. E1 is getting a heart. E3 is getting a king. Okay. E3 is getting a king. Okay. In heart, one king will be there. Okay. In out of 4 kings, one king will be of the heart. So here one king will be of the heart. Okay. So one king will be of the heart. So what is common between E3 and E1? There is only one thing common. That is N of E3 and E1. E3 intersection E1 will be 1. How? Because there is one king which belongs to heart. Okay. Here there is one king which belongs to heart. One king which belongs to heart, because E1 is talking about getting a heart, E3 is talking about getting a king. Okay. So E1 is talking about getting heart, E3 is talking about getting a king. So one king which belongs to heart. So that is N of E3 E1, E3 intersection E1 is 1. So probability of E3 intersection E1 is what, friends? E3 intersection E1 is 1 by 52. Now look at this. E3 or sorry, E3 E1 intersection E2 intersection, because we have to find for this. Okay, this we got, and this we got. Okay, we have to find this E1 intersection E2 E3. Okay, for this E1 is what, friends? Observe carefully. Observe very carefully. E1 is getting a heart. Okay. Next is E2 is getting a red card. E2 is getting a red card. Out of E1 and E2, what is common, friends? Out of E1 and E2, what is common? Okay, red card and heart. Red card, out of red cards, there are two types of red cards, diamond and heart. Okay, E1 is talking about heart. So from E1 and E2, what is common? 13 is common. That is getting a heart. That is getting a red card. That is heart. Getting a red card. One of the type of red cards is heart. So how many hearts are there? 13. Okay. Now E1 intersection E2, we got it as 13. Now with that we have to do intersection with E3. E3 is getting a king. E3 is talking about what, friends? E3 is talking about getting a king. When we talk about getting a king, okay, out of 13 hearts, getting a king is, there is only one possibility, that is only one king, which belongs to a heart. So E3 is talking about a king, and E1 is talking about a heart, and E2 is talking about a red card. So a heart belongs to a red card. Okay, out of the heart, there is a king. So the common between E1, E2, and E3 is 1. That is what I'll write it here and show it to you. E1 is talking about what? E1 is talking about heart. E2 is talking about red card. E3 is talking about king. So we get a king which belongs to heart, and heart belongs to red card. Correct? No? So how many kings are there? There is only one king. Only one king. So E1 intersection E2 intersection E3 is n of E1, n of, for this n of E1 intersection E2 intersection E3 will be equal to 1. Will be equal to what, friends? Will be equal to 1. Got it, friends? N of E1 intersection E2 intersection E3 will be equal to 1. So what will happen? P of E1 intersection E2 intersection E3 will be equal to what, friends? Will be equal to 1 by 52. Now if I write the formula again, observe carefully. We need to find P of E1 union E2 union E3. Okay, before the formula I'm writing again so that you remember. See here, it is P of E1 plus P of E2 plus P of E3 plus, it is not plus, it should be minus. Okay, although I'm taking time for this question, but this question is very important. They can ask in many different ways in the upcoming examination. So you have to know the basics of this. It is good that they ask for 3 events. E1 intersection E2 minus P of E2 intersection E3 minus P of E3 intersection E1 plus P of E1 intersection E2 intersection E3. Got it, friends? What is P of E1? What is P of E1? What is the P of E1 we got? That is 13 by 52. See here, that is 13 by 52 we got. P of E2 is how much? 26 by 52. What is P of E3? That is also what? Getting a king. P of E3 is, getting a king is, there is not 13 by 52. It should be, n of E3 is 4. It should be 4 by 52. It should be 4 by 52. It should be what? 4 by 52. Okay, friends. So if you put the values here, this is 13 by 52 plus P of E2 is 26 by 52. This is 4 by 52 minus P of E1 intersection E2. What is that? We got it as 13, I think. See here. This is 13 by 52. Next is 2 by 52. Next is 1 by 52. So that is 13 by 52 minus 2 by 52 minus 1 by 52 plus P of E1 intersection E2 E1 intersection E3, that is also 1 by 52 plus 1 by 52. Now if you see what I can do, I can cancel this and I can cancel this, plus 13 by 52 minus 13 by 52. Next is, this is minus 1 by 52 plus 1 by 52, I can cancel. Okay, next what I can cancel? Nothing. So this, we will be left with what? We will be left with this much here. Denominator will have 52, the numerator will have 26 plus 4 minus 2. Okay, so this will be equal to 30 minus 2 divided by 52. So that will be equal to 28 by 52. So this is how much, friends? This is 2 14s are 2 26 are. So 2 7s are 2 13. So the correct answer is 7 by 13. So here the correct answer is 7 by 13. Okay, what is the option that is given? Although we took a lot of time, you gained a lot of knowledge when it comes to cards. So here the correct answer is this option, 7 by 13. So this is the correct option, friends. So for this question, there are 3 events. You have to remember this formula for 3 events. First of all, I told you the basics about cards. Okay, I told you the basics about cards. What are the type of cards? Okay, what are the colors with respect to cards? And then we learned the probability of finding for 3 events. That is union of 3 events as per the PYQ question that is given. That is IIT JAM 2024. And based on that, we found out the answer, that is 7/13. Like this, you have to find. All right, friends. I hope it is clear. Let us move to the next question. We spent a lot of time on this question. I hope you gained a lot of knowledge with respect to the questions based on cards. Now let us move forward. Okay. Okay, answer I have already given. Anyways, we have to know how to solve. Okay, answer we have already given. You shouldn't have given, it's okay. It's not about getting answer. You have to learn how to get the answer. You have to gain the knowledge. Okay, here it is given as 0.75. No problem. So, how to get 0.75? First of all, they're telling if a fair coin is tossed. Fair coin means what? Fair coin means unbiased coin. Unbiased coin, it is having head and tail. Okay. One side is head, another side is tail. It is not having head and head. It is not having tail on both sides. Head and tail on either side. One side is head, another side is tail. Fair coin means unbiased coin. If a fair coin is tossed 2 times, okay, one fair coin is tossed 2 times, the probability that the first, okay, or the second be heads is, the probability that the first or second be heads is. So, what is the event that is given? This I will solve in 2 methods. So, listen carefully. This I will solve in how many methods? This I will solve in 2 methods. Okay. So, when we toss a coin, first event is talking about probability that the first is head. Suppose I toss a coin like this. First time, probability of getting a head first time, or probability of getting head second time, that they are asking. Okay. First time if I probability of getting a head. Okay. Getting a head. Okay. If I toss it 2 times, what are the things that can happen? That is, it can be head, tail, or it can be both head, head. This is first time head. Next is E2 is getting a head first. This is getting a head first. This one. Getting a head second. Getting a head for second time. Second. Okay. So this will be how much? So this can be written as TH or HH. So second is H. Okay. Second is H. And also here also second is H. So friends, this is how much, friends? This is N of even is how much? N of even is 2. Here also N of E2 is 2. What do we talk about sample space? When we talk about sample space, here sample space can be what? When we toss 2 coins, okay. When we toss a coin 2 times, okay. First time it can be head and second time it can be head. First time it can be head, second time it can be tail. Or first time it can be tail and second time it can be tail. Or first time it can be tail or second time it can be head. Okay, these are the possibilities. Okay, so n of cardinality of S is how much? 1, 2, 3, 4. So it is 4. Correct? No? So it is 4. Now this is what we get. Okay. So this is what we get. Now, when I talk about the formula, in the formula we know that even intersection E2 is there. When we talk about union, even intersection E2 is there. Even intersection E2, when we talk about even and E2, what is common? See, first getting head and second tail. First getting tail and second head. That is not common. What is common? Head and head is common. Here also head and head is common. As per the even, head and head is common. So that is what head and head is common. So cardinality of even intersection E2 is how much, friend? Cardinality of even intersection E2 is, friends, it is nothing but 1. So now I'll write probability of even is what, friends? Probability of even is 2 out of 4 because n of s is 4. Okay. Probability of E2 is how much, friends? Probability of E2 is 2 out of 4. No need to cancel here. Probability of even intersection E2 is how much, friends? It is n of even by E2 divided by n of s. N of s is 4, that is 1 by 4. So what is the formula that we have? What is the formula that we have, friends? The formula that we have is probability of even union E2. Okay, because they're telling, see, look at the question. Observe the question carefully. They're telling if fair coin is tossed 2 times, the probability that the first or second, they're telling or. Whenever or comes, I told you it is union. I told you it is union. Okay, I told you it is union. This is the first method I am using. First method, we'll use the formula method. Using the formula method, we are solving. Okay, using the formula method. So this formula is nothing but P of E1 plus P of E2 minus P of E1 intersection E2. So this will be equal to 2 by 4 plus 2 by 4 minus 1 by 4. So this will be 2 by 4 plus 2 by 4 is 1 by 2 plus 1 by 2. Okay, so that will be equal to 1 by 2 plus 1 by 2 is 1. 1 minus 1 by 4, that will be equal to 4 minus 1 by 4. So that will be 4 minus 1 by 4 is 3 by 4. 3 by 4 is nothing but 0.75. 3 by 4 is nothing but 0.75. In all the answers which you are getting, observe carefully. It is ranging between 0 and 1, the answers which you are getting. So answer can be 0 or 1, or it can be between 0 and 1, but never less than 0, never greater than 0. I'm talking about probability. So same thing we got. That is what? Same thing we got 0.75. 0.75. This you can write it as, first method. Which method? First method. That is using addition theorem. Using addition theorem. Okay. Next method, I'll write it here. Where is the space? See here, friends. Let me write it here. This is second method. This is second method. So see here, friends. A coin is there. Okay, a coin is there. What we have to do? That coin is tossed. Okay, this coin is tossed. What we get? Head, tail. Again, if this coin is tossed, what we get? We can get, what are the possibilities? We can get head. For this head, we can get another head, or for this head, we can get another tail. For this tail, we can get another tail, or we can get another head. So what are the total number of sample space here? 1, 2, 3, 4. So here n of s is 4. Here in this question, here n of s is 4. So what are the, for the event that we are talking, getting first as head is this one, getting first as head is this one, or getting second as head is this one. So the possible number of outcome, favorable outcomes is this, and this. Getting first coin as head is this one, this one. Getting second coin as head is this one. So if you combine, how many are there? 1, 2, 3. So n of e is, how much, friends? N of the event is 3. So probability here it will become, so I'll write it here. Probability of event is n of e divided by n of s. So it is 3 by 4. That is nothing but 0.75. You can solve it like this very fastly also. Second method without using addition theorem. Okay, friends. Next thing. I hope it is clear. Let us move to the next question. Here also answer is given, no problem. See, a deck of 10 cards is given to you as shown below. One card is drawn at random from this deck. The probability of selecting a number less than 9 is. So here the sample space is 1 to 10. So n of s is nothing but 10. Okay. Here event. The event is about getting a number getting less than 9. Okay, getting less than 9. That for that it can be, what are the possibilities? Possible outcomes 1, 2, 3, 4, 5, 6, 7, 8. They're not telling getting number 9 or less than 9. They're telling less than 9. So it is 1, 2, 3 up to 8. So here n of s will be how much, friends? Here n of e. N of e will be, n of s will be 10. N of e will be 8. So probability will be, P of e will be, friends, cardinality of e divided by cardinality of e divided by cardinality of s. So that is equal to how much, friend? That is equal to 8 by 10. So that is equal to 0.8. Same thing. Same thing we got. That's all. Simple. This is a very nice question. They are telling, look at this question very carefully. They are telling, if a coin is tossed 3 times, what is the probability that no 2 successive tosses show the same face? no two successive tosses show the same phase. Okay, no two successive tosses show the same phase. So one thing you must understand, I told you for n of s, let it be here. Let us not use an addition theorem here. Let us solve using tree diagram. No two successive tosses. That is, no two successive tosses means suppose two successive tosses are there. Okay, it should not come as head head, or two tosses are there. It should not come as tail tail. Or suppose three tosses. Three coins means three tosses. So T H H or H T T. See here, H H T or T T H. So here successive tosses are same. Here also successive tosses are same. Here also successive tosses are same. So here also successive tosses are same. So like that we have to not get. Okay. What is the probability that no two successive tosses are showing the same phase? Anyways, I hope it is not clear now. When I draw the tree diagram, you will understand. See here, n of s. Here it is. When you throw a coin, what are the outcomes? It can be head or tail. So there are two outcomes. Okay. Okay. I told you if they're tossing a coin one time, it is 2 to the power of n. N is here equal to 1. If it is tossing one time or tossing one coin. Here you are tossing three times. So n will become equal to 3. So 2 to the power of 3, that is equal to 8. So n of s will be equal to what? 8, friends. N of s will be equal to what? 8. Now let us use the tree diagram. Suppose this is the coin. Coin is tossed. This is head. This is tail. Okay, that is a possibility we get. That is what I have written 2. Okay. So again, if it is tossed, first time tossing, first toss. This is second toss. Okay, this head can be giving, this head will get another head, or we can give another tail. This tail can give what? This tail can give another tail, or it can give another what? Another tail or another head. Okay, now if you toss it third time, they're asking for this one. This is highly important. Okay, this is the thing we have to focus. The probability is with respect to this one, third toss. They're not asking for first and second toss, they're asking for the third toss. So we have to focus here. So this head and head can give two possibilities. Head and head can give another head, or this head and head can give another tail. This head tail can give another head, or head tail can give another tail. Okay. So similarly, this tail can give another head, or this tail can give another tail. Okay, another tail. So tail head can give another head, or this tail head can give another tail. Now if you see consecutively, you should not get the same toss. Consecutively, you should not get the same outcome. Here consecutively you are getting two outcomes should not be same, but here three outcomes are same. So definitely this is not possible. Here two outcomes are same. See, look at the question. They're asking what? Probability of here probability that no two successive tosses. No two successive tosses means what? No two successive tosses means one after the another. It should not show the same phase. It should not show the same phase. So probability of not showing same phase we have to find out. So we have to eliminate those things that are showing same phase. Okay, so this is showing same phase, so this is showing same phase. Here HTH, this is not showing same phase. So first of all, you count number of sample spaces 1 2 3 4 5 6 7 8. That is what we got here. That instead of writing like this, we got it directly 2 power 3 8. This I have proved it how we got 8 here. See here, this is not possible because we are getting same phases again and again. Here HTH, it is not consecutive. First you are getting head, then tail, then head. It is not consecutive. So this we can consider. Okay. So next is head, tail, tail. Because we are getting same tail and tail. So this is not possible. So here tail and tail is there. So this is not possible. Here tail, tail, tail is there. This is not possible. Here tail, head, head is there. This is not possible. This is tail, head, tail. So this is correct. This is possible. So out of these number of outcomes, the favorable outcome is how much? 1, 2. So probability of event is that no successive coins are having the same phase. So probability of event is here n of event will be how much, friends? N of event will be 2. That is this one and this one. Okay. So n of event will be 2. So that will be 2 by 8. 2 by 8 is how much, friends? It is 1 by 4. That is nothing equal to 0.25. So here the correct answer is 0.25. Got it, friends? Here the correct answer is 0.25. This is IIT JAM 2022. Okay, this question is IIT JAM. IIT JAM 2022. Okay. This is 2017. This is 2017 PYQ. Okay. This is PYQ 2017. Let us move to the next question, friends. One more question is there. Okay. This question, we will do it later because you have to have the knowledge of sets, subset, and all these things. So when we do the chapter of sets, relations, and function, we will do this after sets. After sets chapter. Okay. After sets chapter, we'll come back and do this. Okay. Sets chapter solve later. Okay. For sets chapter, we will do this question because you need to have the idea of sets. Okay. Now, this is IIT JAM 2017. Got it, friends? This is IIT JAM 2017. I think this is 2019. Okay, that question was 2019. Okay, anyways, last question for the day. After that, we'll wind up the session. Please listen to the class. Please let us solve one more question. Listen to the class. Listen to each and every word very carefully. They're telling 2 dice are thrown simultaneously. 2 dice are thrown means what? What is the number of possible outcomes when a dice is thrown? 6. Correct? No. Sample space when a dice is thrown is 6. So n of s will be 6. Okay, but 2 dice are thrown simultaneously. 2 dice means 6 to the power of 2. So n of s will be 6 to the power of 2, that is 36. N of s will be 36. What is the probability that the sum of the numbers is obtained is divisible by 7? Sum of the numbers obtained is divisible by 7. So first of all, to get 7, what are the possibilities? So event is sum of the numbers is divisible by 7. So first of all, to get that, what are the possibilities? It can be 1, 6. Another can be 2, 5. Another can be 3, 4. Another can be 4, 3. Another can be what? 5, 2. Another can be 6, 1. Okay. So 6, 1. So here, how many favorable outcomes? 1, 2, 3, 4, 5, 6. So n of e is nothing but equal to 6. And they're asking sum of the numbers is divisible by 7. Here sum of the numbers is what? 7. Okay, here it is 7. Here also it is 7. Here also it is 7. Okay. So divisible by 7 means you must understand what are the numbers divisible by 7? It is 7, next 14, next 21, like that. But when it comes to 2 dice, okay, what is the minimum value can you have? When you throw 2 dice, minimum value you can have is 1, 1. That is 1 plus 1, it will be equal to 2. This 2 is not divisible by 7. Another maximum value that you can have is 6, or 1, or maximum value you can have is 6, 6. That is, if you add this, it will become 12. So the value which you are looking for is lying between 2 and 12. That value is nothing but 7. So for 7, we got this favorable outcomes. 14 you won't get when you throw 2 dice. If you add any number, you are not going to get 14. Maximum value is 12, and minimum value is, there is no 0. Okay, always there is a value that is 1. Minimum value is 1 in each dice. So 1 each in 2 dice means 1 plus 1, it will be 2. So it ranges between 2 and 12. What is the value that is divisible by 7? Between 2 and 12, that is 7 itself. So we got the favorable outcomes when it respect to number divisible by 7. The number divisible by 7 is 7 itself. So the favorable outcomes, we got it as 6. So probability of E is nothing but 6 by 36. That is nothing but equal to 1 by 6. 6 1s are 6 6. So here, friends, their correct answer is 1 by 6. Okay, this you have to remember. 1 and 1 is the minimum value when it comes to 2 dice. When it comes to 3 dice, 2 dice, maximum value is 6 and 6. When it comes to 3 dice, minimum value is 1 1 1, that is 3. and maximum value is 666, that is 80. Okay, I am talking about 3 days. Okay, so these are the questions. Okay, this is also a PYQ IIT Jam 2017. So we solved a lot of PYQs today based on axiomatic approach to probability. I hope the session was useful. So let's wind up the session. So let us meet tomorrow. Okay, let us meet tomorrow morning with another topic of probability, that is conditional probability and its properties. Next will be conditional probability and its properties. Okay, I hope the session was useful. Thank you for attending the session. Let's meet in the next class. Take care, friends. Bye.